Benzene and its derivatives. In this session, I will focus on the reaction of benzene. There are four types of reaction. One is halogenation. Halogenation is, okay, just remember, all of the benzene reaction we are learning here, they are called the electrophilic aromatic substitution reaction. So you can see here the hydrogen is substituted by electrophile. Okay, so if you have halogen, then the hydrogen is substituted by halogen. And the easiest one is look at the concentrated nitric acid, then it will be substituted by nitro, NO2. So the process is called nitration. Now the difficult part will be the Friedel-Crafts alkylation because the alkyl can be rearranged. Okay, then the last one will be Friedel-Crafts acylation. As you can see here, there is a carbonyl group here. Okay, so I will only focus on Friedel-Crafts alkylation and also Friedel-Crafts acylation as how to get the product. Okay, so first of all, you can see that the hydrogen will be substituted by the alkyl group. Okay, so how to draw them? Okay, for example, if we look at the general equation, reaction equation, it is starting from benzene and then the reagent. But because I want to draw the product, so what I will do is I usually put the haloalkane on the left. Okay, why do I do this? Because you can see I want to substitute the product. Okay, so what I do here is I will always put the halogen and the hydrogen side by side, because when it is eliminated, then you can combine the alkyl group to the benzene ring. Okay, however, you can see here we have primary, secondary, and also primary carbon. Why do we only combine or substitute with the secondary carbon? Okay, because secondary or tertiary is more stable. Okay, so let us look at another example. This is a primary haloalkane, but the major product is benzene. Okay, so you can see here when it is attached to the benzene ring, now the carbon has become secondary. And then if we undergo rearrangement, we will get this carbon is becoming tertiary. Therefore, tertiary is more stable than secondary. So we have more products formed. Okay, so it means that it will undergo rearrangement for mechanism. So remember, Friedel-Crafts alkylation, when you want to combine the product, you have to find out, can I get primary, secondary, or tertiary? Now, let's look at one example here. Okay, Friedel-Crafts alkylation. Okay, so when it reacts with one chloroethane, we can see here this is primary carbon. This is also a primary carbon. Okay, so you don't have to do any rearrangement. Okay, so you can just attach to any of the carbon. Okay, now next one. I have halogen here. Okay, so I can have secondary. Okay, the one that attached to the chlorine is secondary. If I just shift rearrangement, I can get primary. And I also can get, if I shift another one or rearrangement, I can get tertiary. So tertiary is more stable than secondary, is more stable than primary. Therefore, it will undergo rearrangement, meaning that the tertiary carbon will be attached to the benzene. Okay, so HCl is eliminated. You will think that, oh, this is the carbon that going to attach to the benzene ring. However, because of the rearrangement, it's actually attached to the next carbon. So if you put in the secondary one from here, then it is incorrect. Okay, now we go for the next one, that is Friedel-Crafts acylation. Okay, Friedel-Crafts acylation, you must use COCl. There must be a double bond here. Okay, so it's the same thing. Usually I will put the acyl chloride on the left hand side because I want to eliminate the HCl, and then I will attach the C double bond O together with the benzene ring. Okay, now this is alkyl benzene. There's a CH3 here, alkyl group here. Okay, so it undergoes oxidation and halogenation, but it is not happening at the benzene ring. Okay, it is happening at the alkyl group, the substituent here. So for this part, the CH2Cl is actually free radical substitution, the mechanism. Okay, which one can undergo oxidation? Okay, so we have to know what is the meaning of benzylic carbon first. Benzylic carbon is the position of the first carbon bonded to a benzene. Okay, so you can see this is the first carbon bonded to the benzene. Okay, so as this part. Okay, so we call this benzylic carbon. Okay, then the hydrogen attached to the carbon, we will call it as benzylic hydrogen. Okay, now what does this mean? Okay, you can see one hydrogen is attached to the benzylic carbon. However, in this carbon, there is no benzylic hydrogen. When there's no benzylic hydrogen, means there will be no reaction. So that's all for this part.